In this video, we're going to be learning the naming system for covalent compounds and how it differs, even though in many ways it's actually more straightforward than the naming system of ionic compounds. Now, the first thing to do is to be able to identify whether a compound is covalent or not, and that's relatively easily done because, by definition, covalent compounds can't have any ions because then they would be ionic compounds. This means you will pretty much never see any metals within a covalent compound, nor will you see any polyatomic ions, even though most individual polyatomic ions are made exclusively of nonmetals. But the fact that they have charge means that they behave differently than covalent compounds. Because remember, ionic compounds form because of the interaction between positive and negative charge that attract multiple ions together, causing them to form a compound, whereas covalent compounds result through the sharing of unpaired valence electrons between two nonmetals. Now, the good news is when it comes to naming covalent compounds, the first three steps are basically identical to the process of naming ionic compounds, only instead of naming the metal and then the nonmetal, both of the elements are going to be nonmetal. So if we take a look at all of these covalent compounds here, we can see that the first element, chemical symbol N, is nitrogen, and therefore we can, if I can actually spell the word nitrogen properly, we can simply write nitrogen, and that is the beginning of our name for all of these. We recognize chemical symbol O as being oxygen, and so we name it like this. However, just like with ionic compounds, nitrogen and oxygen are the names that we give to individual elements, and so we need to take the suffix of the second nonmetal, which in this case happens to be oxygen, and remove it, and then replace it with the suffix IDE, just like we do in ionic compounds, and if the rules were to end there, then we would have the name nitrogen oxide. Now, the problem is, because there are multiple different ways to share unpaired valence electrons, even if we keep the same elements between multiple compounds, we can see that we have many different nitrogen oxides, and we need additional components to the name in order to distinguish which nitrogen oxide is which, for which we need to use parts of speech that we call numerical prefixes in order to show how many of each nonmetal we have within the compound. Now, if we start simply here, we can see in this nitrogen oxide, we actually only have one of each, and the numerical prefix that we add to the beginning of nitrogen and or oxygen that indicates that we only have one is the prefix mono. You may be familiar with this prefix meaning one. For example, a train that travels only on one rail is called a monorail. So if we wanted to be ultra specific with NO, we could call this mono nitrogen, meaning one nitrogen, monoxide, implying one oxygen. Now, technically speaking, because the number one is just understood a lot of the time, conventionally we only use the prefix mono for the second element within a covalent compound, meaning that you'll often see NO just written as nitrogen monoxide, although if you were to write mononitrogen monoxide, you would not be wrong. The mono is just redundant, because if this number were anything other than 1, there would be a different prefix here. Now, some of you may have picked up on the spelling reduction that we have here, because if we were to just add the prefix to oxide, it would be pronounced monooxide, and this is an idiom of the English language where English doesn't like consecutive vowel sounds next to each other like this, because monooxide involves a rearticulation of the vowel, but if we remove one of these vowels and condense them, we would just pronounce this monoxide, and this is simpler to pronounce. It's just one of the spelling conventions, one of many, that we need to memorize about the English language. Now, if we take a look at the nitrogen oxide to the right, we can see that we no longer have one nitrogen, we actually have two, which means we need the numerical prefix di for two. So this nitrogen oxide would happen to be called dinitrogen monoxide. And again, we write the mono suffix for oxygen to indicate that there is indeed only one, but now we have two nitrogens instead of just one. Now, we can also see that we need a di prefix for the next nitrogen monoxide here, I misspoke, nitrogen oxide here, only instead of using mono, the oxygen requires a di prefix because there are two oxygens here. So rather than dinitrogen monoxide, this we could call again this mononitrogen, or we can drop the mono prefix and just write nitrogen and then add the prefix di to the oxide. And for those of you that are thinking, but what about the consecutive vowel rule? How come we can have an I sound next to an O sound, even though these are consecutive vowels? And the answer is, pay no attention to that. Remember, English is kind of a stupid language that doesn't like following its own rules, because it breaks this consecutive vowel rule all the time. And when it comes to the letters I and O, the only guess that I have is you don't really need to re-articulate the vowel. You can just say dioxide and it flows relatively smoothly. But as we will see many times, English breaks this consecutive vowel rule all the time, much to the misfortune of anyone who wants to learn English with any regularity. Now, the next nitrogen oxide here, we see that we have three oxygens in the chemical formula and in the chemical structure, which means we need the prefix tri. And this is a very common prefix. For example, a three-sided shape is a triangle, or a three-wheeled pedaled vehicle is called a tricycle. So this compound here would be called dinitrogen, because again, there are two nitrogens, and then we would use the prefix trioxide, and yes, we see the consecutive vowel rule is broken yet again, but again, trioxide flows relatively nicely when pronounced. Next up, we need to know the prefix for 4, because we have 4 oxygens here, and this is the prefix tetra, which is not a very common prefix in everyday speech. In fact, the only English word that I know of that contains the prefix tetra is referring to a triangular-based pyramid where every face is an equilateral triangle. So a pyramid with 4 identical faces is what we call a tetrahedron, and again, tetra in this case meaning 4 faces, just like the prefix tetra would mean 4 oxygens in this case. So N2O4 we would label as dinitrogen tetroxide, and here we have the consecutive vowel rule being actually used here, because if we were to write the prefix without dropping either of the vowels, we would pronounce this tetraoxide, and you kind of need to re-articulate the vowels here, so instead we drop the A and just pronounce this tetroxide. And finally, or rather our final example, nitrogen oxide compound requires a prefix for 5. And for those with good knowledge of basic geometry, you'll recognize the prefix penta as in the word pentagon, which is the name for a 5-sided shape. And we can use the penta prefix for this compound here. So we have 2 nitrogens, which again is going to be dinitrogen, and here we use the consecutive vowel rule because pentaoxide would be a little bit clunky to pronounce, and so we just reduce this to dinitrogen pentoxide. Now, these are easily the most common 5 prefixes used, but that doesn't mean that you won't see numbers 6 to 10, so we can add these prefixes quickly. The prefix for 6 is hexa, which is easy to remember because a 6-sided shape is a hexagon. The prefix for 7 is hepta. Again, a 7-sided shape is a heptagon. Prefix for 8 is octa, most famous for octagon, like Canadian stop signs are all octagons. The prefix for 9, some pronounce it nona, I personally pronounce it nona, either. And finally, the prefix for 10 is pronounced deca. So, with a basic understanding about how to name each of the nonmetals within a covalent compound and how to use numerical prefixes, as well as what the numerical prefixes from 1 to 10 are, you can try the practice problems below. This actually concludes this part of the video series on covalent compounds, and once you test your knowledge of naming covalent compounds using numerical prefixes, you can take a look at the practice problems below, which will review your knowledge of how to construct Lewis structures of covalent compounds, including how to count valence electrons, how to determine the central atom, and how to draw the Lewis structure of the compound, and at the end, you can test your knowledge on a little more covalent compound naming, and you can join us in the next series of videos which will look at chemicals when they react with one another.